Let's begin with the obvious. The primary obstacle to fisheries adopting ropeless, or on-demand, fishing is the resolution of gear conflict that is created by the removal of the surface buoy. And the best way to solve this problem is for fishermen to see what is on the seafloor around them in real time. This includes not only the trap fishermen, but all the mobile gear fishermen that also need to know the existence and location of gear sitting on the bottom. Ropeless Systems has developed a hands-free, chart plotter integrated, real-time acoustic gear location system that automatically allows fishermen to see the gear on the bottom. The technology to replace the buoy and see submerged traps on a chart plotter and control the recovery to the surface is available now. It is a solution for all trap fishermen, mobile gear fishermen, and enforcement agencies. It is worth noting that the removal of end lines and surface buoys from fishing operations to implement ropeless fishing created a unique situation, a brand new requirement that had never previously existed in ocean technology. For decades, acoustic technology has been used by surface vessels to locate, communicate with, and recover submerged gear from the seafloor. But the ropeless fishing application created a new problem. It needed to allow multiple vessels in an area to see the locations of multiple seafloor objects simultaneously and without interfering with each other. It also had to distinguish single traps from connected traps, trawls, and associate and display trawl ends, distinguish gear ownership, and limit recovery and control to the owner. Such a capability had never been required in an acoustic device or system until ropeless fishing was proposed. As it turns out, it's a very difficult task. It has taken us a few years, significant engineering effort, and a great deal of investment, but we have the solution to the problem. To date, everyone has been told that there is only one solution available for gear conflict resolution, and that is GPS-based gear location marking. But the technology of that approach does not answer the question of where things are truly located on the bottom. Instead, it says, this is where someone said things were reported to have been deployed at the ocean surface at some point in the past. But where is it on the bottom? Is it still there? Was it ever there in the first place? This approach simply cannot tell a fisherman where something actually is at the moment he needs it most, which is now, so he can decide where to set his gear and avoid other gear. So what would you prefer? You can have an inaccurate GPS-based reporting system that requires fishermen to report all their trap locations to a shoreside master database, or you can have a vessel system that allows real-time visibility on a chart plotter showing where all the submerged gear is actually located on the seafloor in the vicinity of the vessel. You can have a GPS-based reporting system that requires broadband ship-to-shore satellite equipment and subscription services, or you can have state-of-the-art acoustic location technology that allows you to see gear on the bottom in real time on your chart plotter. All of the challenges with GPS gear location marking are overcome by real-time acoustic gear location. So why estimate position based on old surface location data when you can know the positions on the bottom in real time and see them on your chart? The technology is available today for adoption by fisheries and for licensing to equipment manufacturers. So let's see what real-time gear location looks like with the latest Ropeless Riser MTA system in action on our research vessel, Decibel, in Narragansett Bay, and also on commercial fishing vessels. The in-water acoustic system is initially deployed, plugged in, and running, and does not need to be touched again between each deployment and recovery. It is launched at the end of a trawl and automatically appears on the chart plotter as a circle with a black X, indicating that it's part of a trawl. But there's no line yet because the other end has not been deployed. When the second end of the trawl is deployed, another green circle with a black X appears, and now you can see a line between the two, indicating that the two ends are connected together in a trawl, all done automatically and hands-free. When another vessel comes into the area in which this trawl was deployed, it will display as red circles with an X and a line between them. This vessel will see the non-owned gear, but will not be able to recover it. When the gear owner wants to recover the trawl, they simply click on the icon on the chart plotter and initiate recovery. The in-water unit confirms receipt and replies with status that it is coming to the surface. There's no transducer to then hang over the side, no deck box to manage, no applications on phones or tablets that need to be operated on deck. Let's look now at the enhanced features for the underwater unit to improve overall operations. First, it's been modified to have an air-saving feature in which the MTA senses that it has left the bottom and shuts off the valve to conserve air. In this underwater video of a recovery, you can see the green light going on, indicating that it has received the actuation signal, starts to rise, and then the green light shuts off, indicating that the unit has sensed it has left the bottom and no longer needs to be putting air into the bag. This air-saving feature is significant because it allows multiple deployments from a single air supply. Another enhancement is there is no need to reset the acoustic system by plugging and unplugging. The only operation is to deflate the bag and roll it back up. The unit automatically starts working again when thrown into the water. This overall operation will allow fishermen to be able to recover and set their traps faster than they can now with traditional methods, saving many hours on a trip. Let's take a look at the acoustic positioning on the chart plotter display and control. Every time we've gone out and deployed our gear here at Ropeless Systems, we record the GPS location where the units went into the water at the surface, and our acoustic system then shows us where they really landed down at the bottom. We've been amassing a large data set to come up with some estimates. Data from our trials, in which we record dozens of single ping positions to each unit, allows us to assess two things. First, the distance or offset between the surface location, marked by the GPS, and where it landed on the bottom. And secondly, the accuracy of any one of our single ping positions. Averaging the entire set of positions allows us to determine location on the bottom to better than 1 meter. Our trials to date indicate that, in water depths of about 40 to 80 feet, we're seeing an average of 30 to 50 feet between where the GPS position was marked at the surface and where it landed on the bottom. In cases where a delay in marking might occur, the distance can be hundreds of feet. We anticipate that the differences will only increase as one deploys in deeper and deeper waters offshore. As far as the accuracy of single ping positions goes, we've been able to determine that our ranging is good to 1 meter and our angular position is good to about 1 degree. This is more accurate than the current surface buoys can mark the location of a trap down on the seafloor. The acoustic approach does raise an important issue, namely acoustic interoperability. It has been stated in the past that these acoustic systems must be interoperable and function similar to cell phones. So let's explore that cell phone analogy in a little more detail. Presently, consumers can select phones from several manufacturers, for example, Apple or Samsung, and they can also select a data plan from among several different carriers, for example, Verizon or AT&T. These phones can communicate with each other and are interoperable. The reason this is possible is because all of the different parts of the mobile phone communication systems, the cell phones and the towers, share one common protocol, CDMA, or Code Division Multiple Access. This interoperability through CDMA was achieved not because the underlying technology was a government-developed or government-mandated standard for all to use. Instead, the common technology was developed by Qualcomm and simply licensed to manufacturers and service providers, allowing interoperability. This was achieved through standard business practice of licensing and cross-licensing, all without the need for government mandate to develop and use a specific standard. Essentially, Ropeless Systems has developed the underwater equivalent of CDMA, creating the same scenarios as that for cell phones. As the developer and present custodian of the only technology capable of real-time acoustic location, meeting all the unique requirements of a high-density commercial fishing localization system, we see the fastest way to widespread ropeless adoption is to follow the model of cellular communications. Ropeless Systems stands ready to allow any and all interested manufacturers to license our technology and offer competing products and services to reduce consumer prices. It worked for cell phones, and it can work for Ropeless. Pursuit of an alternate path cannot be accomplished in the timeline needed for fishermen and for the North Atlantic right whale.